Hello, welcome back. I hope you had a very nice spring break and you are ready to continue toward the end of the semester. So what we're going to do, we are going to have a quiz. We are going to have test number 2 on Monday. So I will post a practice test for you. Okay, and then a solution, of course. And then we prepare you to give you the test on Monday. Test would cover whatever we did on the quiz, okay, on the quiz, and then a couple of sections, I go to the up to the 4.6 or maybe 4.7. 4.6 is very important one. 4.7 is easy. We try to see what we can do. So what I'm going to do is I'm going to continue. Remember, we talk about the dimension of a subspace, very important one. Okay, we we define a basis. We define a basis for a vector space, and we arrive at the conclusion that all the bases of a vector space would have the same number of vectors. That same number is going to be called the dimension of a vector space. Okay, so for example, R3, IJK is going to be a basis, so the dimension is three-dimensional one. And we talk about, if we consider the collection of all polynomials, collection of all the polynomials of degree at most n, the dimension is going to be n plus 1. And this is, we give you some examples, especially the dimension of a subspaces. I give you example, and there are going to be quite a lot on the practice test I'm going to give. Okay, now you need to know one more type of examples from that group, and that's the example related to the solution of a system of the linear equations. You know that when we solve a system of linear equation, depends on what type of system you'll be given. Okay, the system may have one solution, no solution, or infinity many solutions. When we get infinity many solutions, then those solutions, if you put them together, those solutions are going to be a subspace. So we are going to have, okay, we call them the vector space of all the solution of a linear system. You know that if you have two solutions, you add them together, you get the new solutions. So this subspace is very important, and we are going to use it later on as well. And so a system of the equation would be given to you, and they ask you to, what is the dimension, or what's going to be basis for the for the space of all those solutions of the system. So the system will have a infinity many solutions. So I'm going to show you how I'm going to do it. This is very popular. Later on, we are going to have a couple of other things related to this one. So you must know the rules, and we are going to give you one of them on this test. Okay, then I will discuss the topics on 4.6. It's easy, but it's a tricky. So you need to be, it need to be explained a little bit. Okay, so let's go. And this is what we did previously. Remember, that was a section that we talked about the dimension, very important one. Okay, dimension and the basis, and that was in section 4.4.5. And I give you various examples. We're going to repeat those examples on your preview, on your practice test. But we didn't cover this type of examples, and you have quite a lot in your book. Okay, so you are going to be a system. Okay, so this is a typical example that you have to know it. Okay, so the question is going to be, they ask you to find the dimension. Okay, find the dimension. Okay, that's it. Find the dimension and a basis, of course. And a basis. In order to find the dimension, you have to introduce a basis. And that base, the number of the vectors in your basis is going to be the dimension. So find the dimension and the basis for the for the solutions. Okay, for the solution space of the system system. This type of system would have infinity many solutions. Even we can go with it when there is one solution. So be patient to solve the system first. Okay, this is the given system. We have the x1 plus 2x2, 2x2 plus 2x3, 2x3 minus x4, okay, minus x4 plus 3x fifth, everything equal to the 0. That's the first equation. And the second equation is going to be x1 plus 2x2, 2x2 plus 3x3, okay, plus 3x3 plus x4 and plus x fifth, which is going to be equal to the 0. And the third equation is going to be 3x1 plus 6x2, 6x2 plus 8x3, okay, plus 8x3 plus x4, x4 plus 5x fifth equal to the 0. Okay, as you can see, this is a system of 3 equations, but 5 variables. So you have more variables than the equations. So this system can have infinity many solutions, because you have to pick some of the variables to be free, because you need in general 5 equations to be able to get the unique solutions. So what we are going to do, as usual, we try to solve it. Let's try to see what's going to be augmented matrix looks like. Okay, so this is going to be our solution. So start with your matrix, and remember you have 5 variables. So the first equation is going to be what's going to be 1, 2, 2, -1, 3, and this is going to be 0 for the constant vector. Okay, the second one is going to be 1, 2, 3, 1, 1, and 0. Okay, the third equation is going to be 3, 6, 8, 1, 5, and 0. Okay, so this is all you are going to have. So this is going to be your augmented matrix. Okay, this is augmented matrix, if you like, just to remind you. This is augmented matrix. So as usual, we try to change it to the row echelon form. Okay, simplified a little bit. Be able to do it. So we got the 1 there. So what we are going to do is, this is it. I take the R2, then I take the R2 minus R1 to make this equal to the 0. Then I have to make this one to be equal to the 0. So I go with the R3, and this is going to be R3 minus 3. I go minus 3R2. Okay, so what is going to be the leftover? So the first one is going to be unchanged. The 1, 2, 2 is a -1, 3, and 0. Okay, the second one, R2 minus R1. This is going to be 0. Okay, this is going to be 0. R2 minus R1. Okay, so that will be 1. And this would be 2. R2 minus R1. So that gives us a -2, and that would be 0. Okay, that's the second one. Now R3 minus 3R2. 3R2, that gives you 0. Okay, 3R2 is a -6, and 6. Make this one into the 0. Okay, then 3R2, which is going to be, okay, so that gives 0, 0. We are here. 3R2, that make it into the 6. So this would be a -2 here. 3R2 give us a, okay, that's it. R3 minus 3R2, that gives us another -2 here. Let's check. That was 3R2. I got the 0, 0. Okay, that's 3 times 3, 9. So that would be a -1. Okay, this is going to be a -1. I got the -2, then R3 here. Okay, and that give me 5 minus 3, which is equal to the 2, and that would be 0. Okay, so this is going to be the conclusion. Okay, to get these numbers. As you can see, if I just add these two together, I get lots of zeros for the last row. So this is going to be R3. So I'm going to add the R3 to the R2. These type of problems are going to be just a few steps that take you to a finish line, if you like. So that's going to be 1, 2, 2, -1, 3, and 0. Okay, and this is going to be 0, 0, 1, 2, -2, and 0. And R3 plus R2, that gives you 0, 0, 0, 0, 0, 0. So you must arrive at this type of situation quickly, because the system would have infinity many solutions. Okay, now as you can see, the last rows happen to be all zeros. So you lose another equations, if you like. Okay, so that should give you infinitely many solutions. The system would be dependent, if you like. So what we are going to do is, remember, you have 5 variables. You have 5 variables. So this means that for the 5, we have only 2 equations. Okay, we have 2 equations. So what we're going to do, we have to pick 3 of these variables to be free. Okay, 3 of the variables to be free. So what I'm going to do is, we are going to suppose I start with this one. Okay, so I'm going to suppose I pick the x5th. Okay, the x5th to be free. I'm going to call it S. Okay, then I pick the x4 to be equal to the t. That is the second one. Then in the meantime, I'll go and find the other one. So in this case, I don't have the x1 and the x2. So that's going to be 3, 4, 5. So I will be able to find the x3. Okay, so this is what I picked so far. I need to pick another one. Okay, so far I can substitute here. Okay, so from here, this is x1, x2. So start with the x3. So I have the x3 plus 2x4 minus 2x5 to be equal to the 0. Now I have the x, I don't have the x3, so I have the x4, so that gives me 2t, and this is going to be minus 2s. Okay, this is going to be 2s, is going to be equal to the 0, so I'm able to find my x3. So this is going to be the x3. Okay, so in this case, I got the x3. I move this one to the other side, so that give me 2s. Okay, 2x minus 2t. Okay, there you are. So now I have 3 of the variables. So if I go to the first one, then I have to take another, okay, one to be free. So the first one's going to be x1 plus 2, okay, x1 plus 2x2 plus 2x3. You can even simplify it a little bit, or just stay as is. So there's going to be negative x4 plus 3x5 equal to the 0. So I got this one from the first equation, but I got this one from the two row, if you like, the second row. So what I can do is, I have the x5th, I have the x4, I have the x3rd. So I need x1 and x2. So I'm going to pick the x2 to be something else. Okay, so I'm going to suppose you have to pick one of them to be. So I pick the x2 to be something like r. Now I can substitute to get my x1. Okay, so for x1, So the x1 is equal to the negative 2x2, negative 2x3, plus the x4 minus 3x3 x fifth. Now, if you substitute, your x1 would be negative 2x2, 2r, okay, 2r minus 2x3, that's 2x3, it's going to be 2 times 2s minus 2t, okay, plus x4, x4 is simply a t, okay, that's it, plus x4, and minus 3x fifth, which is going to be minus 3s. Okay, 3s, you have to simplify it to get this number. So what I have is it's going to be negative 2r, negative 2r. I multiply these together, that gives me negative 4 and negative 3 would be 7. So it's going to be minus 7s. Okay, minus 7s. What else? These two would be a positive 4t, and that gives me 5t. Okay, this is a double check. So this is it. That gives you 45t. So that would be 5t. Okay, 5t minus 3s. 5t minus 3s is going to be the 1. Okay, so I have everything I need. So what we are going to do is we are going to write the, you know that these are going to be, you get infinity many solutions. These solutions all together would be give us a vector space of the solutions of the system of the equation, or the subspace of these solutions. So the solution space is going to be of this format. Okay, let's see if I can put it here to get these numbers. Okay, I just double check that this is going to be my x1. Okay, we have the x1. Okay, let me just write it down. So therefore, the solution of the system is going to be, that's it, it's you have the x1, okay, x2, x3, x4, and your x5, okay? So this is going to be the solution set. Now the solution set is going to be something like this one. For the x1, it's a negative 2r, okay, negative 2r plus 5t, okay, 5t minus 7s, okay, 7s, that's the x1. For the x2, we have the x2 equal to the r, okay, that's going to be x2. For the x3, we have a negative 2t, okay, we have a negative 2t plus 2s, okay, that's the x4. That's it, this is x1, x1, x2, x3, now x4. x4 is equal to the t, and the x5 is equal to the s. You see, this is going to be your solution set, if you like. This is going to be solution set. So the space, or the subspace, if you like, the subspace of the solutions. Okay, the solution is going to be of this format. You see the solution space, or the subspace, the solution. Okay, solutions, the vector space, or the space of the system is going to be in this format, if you like. It's going to be a collection set. We can call it W if you like. So it's going to be the set of these type of numbers, okay? It's a negative 2r plus 5t. I repeat it, minus 7s. Then I have the r, negative 2t plus 2s, okay, comma t, comma s. And this is the case when s, t, and r are free, are real numbers, are numbers. Okay, they're going to be arbitrary numbers. So this is what we are talking about. Okay, so you get many solutions. Your system would have infinitely many solutions. These solutions together is going to be a vector space. Okay, vector space with the ordinary okay additions, because this is going to be the vector addition scalar multiplication. Okay, in this case, this is going to be a subspace of what? A subspace or fifth, if you like, because they are all numbers. So you want to, this is going to be a vector subspace, if you like. Now you want to know what's going to be the dimension. In order to get the dimension, you have to find a basis for this space. Remember, we did this one before. The basis is going to be, so what you can do is you can try to see if you can find a set of vectors that span these subspace generated. I told you the method that we're going to find the other night to break it. So this is the way you can break it. This is it. You can start with you have to rewrite it again. You see this is going to be negative 2r. Try to break it using those 0, 1 that I created. I talked about the other night. You see, I'm going to break it to see how many vectors do I need to be able to do it. So we focus on these variables. We have 3 variables, 3 very 1. That would help us, okay? In future, we are going to give you a theorem, but not now. So what I'm going to do is I'm going to write it down as a linear combination. So what I do, I start with a t. Okay, this means I like t, but I don't like the others. So replace the t by 1, everything else by 0. So this is 0, that give you just 5. So that give you 5, okay? T by 1, everything else by 0. So the second component must be 0. Okay, t by 1, that give you negative 2. Okay, negative 2. T by 1, and s by 0. So that give you t times. You see, this is one of those bases or the basic vectors. Then you continue. You get the other free scalars that you have. So that was ts. If you want to pull out the s, so you are interested in the s, replace the s by 1, everything else by 0. So over here, that gives you a negative 7. Okay, negative 7, comma. And the second one, this must be 0. Okay, this one, you are interested in s only, so this is going to be 0, but the s is 1, that give you 2. Okay, 2, comma. You are not interested in t, but you are interested in s. So that give you the second vector. Okay, and the other variable that you have is r. So it's going to be plus r times. Okay, replace the r by 1, everything else by 0. So that give you a negative 2 here. R by 1, everything else by 0. Okay, everything else by 0. That give you the r. Okay, if you add these together, you will automatically get this one right away. You see the first component, you get a 5t minus 7s minus 2r. And the second component, the same thing. And you see 1, 2, 3, 4. The fourth one, for example, you see the fourth one that give you t here. Everything else is going to be 0. So as you can see, each vector can be spanned by these 3 vectors. So you have a basis. So if you take the basis to be containing these 3 vectors, okay, this 5, 0, okay, 5, 0, negative 2, 1, and 0. And the other one is a negative 7, negative 7, 0, 2, 0, 1. And you have a negative 2, 1, 0, 0, 0. You see, you are able to generate this subspace by these 3 vectors. So this means this is going to be, this is a basis for the solution space, and the dimension of the solution space the dimension of W is equal to 3. Okay, so these type of problems are very popular. That's why I want to make sure that you are able to do one of them for us. Okay, and we have a couple of them in your okay on the practice one that I'm going to post for you. Okay, so that is the leftover. I have another one. I just put it over here. You can try it for yourself. Okay, the example is you want to find the dimension. Okay, find the dimension. You see, if they just say dimension, then we have a theorem. The dimension is equal to the number of the free agent that you get, free variables. So you have 1, 2, 3. So that would be 3. There is a theorem about it when we get to the next sections. But we quickly ask for the basis. Since we asked for the basis, you have to, distribute it and give us the basis. So this is going to be the same for the test. Okay, find the dimension and a basis, of course, and a basis for the system, for the solution space. Okay, solution space of the system. Okay, I give you the solution better than just do it yourself. Just make sure you know it. This is the system. The system is 2x1. Okay, 2x1 plus 2x2. 2x2 minus x3. Okay, minus x3 plus x5 equal to the 0, the first equation. The second equation is negative x1. Okay, minus x2 and plus 2x3. Okay, 2x3 minus 3x4. 3x4 plus x5 equal to the 0. That's the second one. And you have a third one, which is x1 plus x2 minus 2x3 minus x5 equal to the 0. And the last one is x3 plus x4, okay, plus x5 equal to the 0. Okay, it takes a little bit more time to take care of that, the system of the equations, if you like, but not bad. Eventually, you'll be able, to take care of this one. Okay, so I just leave it for you to do it. So the solution is going to be, you see, this is going to be your final answer that give you x1, x2, x3, x4, and the x5. You are going to have two free agents. You get negative s minus t. Okay, and this is going to be s, and this is going to be negative t. Okay, and this is going to be 0, and this is going to be equal to the t. Okay, if you solve this system, x4 would be 0. So you're just using two variables, and easily you can expand it. Okay, you can expand it. For example, you can take out the s, so you like the s, you don't like anything else. Replace s by -1 by 1, so that give you 1, and that would be 0, 0, 0, and then pull out the t. So you pull out the t, then you like the t, so replace the t by 1, anything else by 0, so that give you -1, 0, -1, 0, and 1. You see, and that's it. You can create it by just two vectors. So your basis is going to be containing two vectors. Okay, containing two vectors. So the dimension of the subspace is going to be, so this is a basis. Is the basis, and the dimension of that subspace that we talk about it, dimension of W is going to be equal to the 2. Okay, so it's quite interesting group of problems that would be very useful. Okay, get to know them. We are going to, you need them when we get to the next sections. Okay, and then we have a theorem. We can predict the results, but we always arrange it so that you be able to. You have to do one of these for us. Okay, so that's a very nice example of these vector spaces. Okay, so that was the thing that because you have a couple of them in your practice one and some problems in your book. So I just want to make sure you know how to handle these type of problems. Okay, so this is all we need to know about that section, very rich section 4.5, the dimensions. Okay, now what I'm going to do, I'm going to explain one more section for you. This 4.6. It's not difficult, it's easy, but it needs to be explained for you. Okay, remember these bases that we talked about it so far? So we introduce a basis. Now we use it in order to define the dimension. So what we did is, again, we have one classic example, which is the Euclidean space Rn. Okay, so we create an abstract format, which is going to be a vector space. So for our vector space, we can have okay, we can have a basis. But remember, we talk about and it's something else. We talk about if a basis is given to you, each vector is a linear combination of the vectors, the basic vector, if you like. Then we introduce the so-called coordinate vectors. It was in your quiz, going to be repeated again. Okay, we introduce the coordinate vectors. The role of the coordinate vector is show that each vector space can be a kind of a copy of Rn, if you like. So in geometry and in physics, sometimes when you have a vector space with a given basis, sometimes you are going to have several bases. You can have several bases for a given vector space, but sometimes you prefer to work with a special basis. Okay, the one that you like it. So there's going to be an argument that we call it change of basis. We want to know because if you have a basis, the vectors of the linear combination of the given basis. But if you change the basis, those coordinates will be changed. We want to know if you can do it quickly, okay? So this argument, again, very popular for some interpretation of geometrical problem in linear algebra and somewhere else, okay? So this is 4.6, very important section. And this is, we call it change of base. Okay, change of basis or basis. Okay, let's see what does it mean. We are going to find out what is there. If we change the base, what's going to be a relationship between coordinate vectors? So we just remind you, see, suppose V is a vector space. V is a vector space. Okay, it's going to be vector space. And we have a basis, B equal to, as usual, B is equal to, let's say, U1, U2, up to the UN is going to be a basis, okay, a given one. A basis, okay, a basis for V. So you have a vector space and a basis. These two is given. So what we want, you know that if you pick a vector, okay, if V is going to be a vector in the vector space V, then relative to these spaces, we can have remember coordinate vectors. Then the coordinate, okay, the coordinate vector of this vector V relative. Okay, relative to B is what? You know that is denoted by or given by, denoted by, remember the notation that we use? This is the vector V and this is going to be the basis. Those are scalars, you know that. You write V as a linear combination of U1, U2 to the UN. Those coefficients, we call them coordinate vectors. So this is going to be what? It's going to be C1, C2, up to the Cn. Okay, this is going to be coordinate vectors. Now the question is going to be, we call this one the old one. Okay, now suppose I give you a new one. So this is the given one, we call it the old one. Suppose you be given a new basis, B prime. So this vector V would have a coordinate relative to the B prime too. So you have one coordinate vector with respect to the B, and you have one coordinate vector with respect to the B prime, the new one. You want to know what's the relationship between these, because we don't want to rewrite it. You see, the question is going to be, if you have one of them, can you quickly find the new one? Okay, this is the problem that we call it change of basis. So if you change the base, you are going to change these scalars. So is there any relationship between the old one and the new one that enable you to find it quickly? Okay, so that's the idea of this section. So basically what you did over here is a kind of a function, a transformation we call it. A function that take the V into the, okay, this is a kind of V to the, you see this is this kind of, this is going to be like a function, if you like. It's like a transformation that transform a vector V, if you like. Okay, a vector from a vector space into what? Into the Rn. Because you pick your vector and the result is going to be just this good. So what we would like to know is, this is going to be our problem. The problem is, if you change the B into the new one, okay? So again, we are going to give it a name. And so the problem is, suppose, okay, suppose B is, we call it B is an old basis, given one. And old basis for a vector space, B, and B prime is a new one, the second one. B prime is a new one. We call it old and the new, so be able to connect. Okay, a new basis for all the vector space B. The question is how these scalars are related to each other, how these coordinate. Okay, so the question is going to be, how are the coordinates? How are the coordinate vectors? Vectors, you see, this is one of them. This is a coordinate vector respect to the old one, and this is going to be a coordinate vector respect to the new one, B prime. How these, how are the coordinate vectors B and C related to each other? Okay, related. This is going to be the question. Okay. So is there any relationship between these two that you can find it quickly? Because if you want to do it in general, it takes time. I'm going to do a special case for you just to believe it. Then I write a theorem for you, okay? A special case, of course, is if you go to the two-dimensional. If you go to the two-dimensional, you can write down everything and try to find it, okay? So this is what I'm going to do for you. So the solution of this problem, be patient. The result's going to be an easy formula, but you have to understand it. Okay, that's case. So we go with a special case. Okay, we go with the special case. What is going to be the special case? So just pick two of these. Okay, pick the B and the B prime in two-dimensional. So you suppose the old one, the vector on the old one is going to be U1, U2, that's the old one. And you pick the new one. And you pick the new one, B prime to be what? B prime to be U1 prime and the U2 prime. Okay, that's going to be B prime. Okay, and this is it. And this is it. Let a vector. Okay, let a vector V in the vector space. Okay, in a vector space. You know, the vector V in R2, of course, in this case. Okay, a vector V is, suppose a vector V is simply is given. Okay, that's going to be one. So what we would like to do is, you see, we want to find a relationship. You already got this one. You already got this one. You want to know what's going to be the coordinate respect to this new one. Okay, you know that you have to write the V as a linear combination of these vectors, if you like. Okay, to be able to find the coefficients to get these numbers. But V is already is what? So V is going to be, yes, we got the linear combination of these two and we connect them together. But the thing is that this U1 prime and U2 prime, you see, these are going to be what? Since we want to use it, so what we can do is we can find a linear combination of U1 prime and U2 prime. We can find the coordinate vector respect to the B here. Okay, and then go with the V. Or you can write V as a combination of these two together, then you have to connect them together, connect them to the original one. So I start with this one, okay? Suppose, okay, I pick this new one. This is U1, okay, U1 prime. What I'm going to do, I go U1 prime. U1 is a linear combination of U2, U1 and U2. And okay, that give me a vector, okay? Give me a coordinate vector. This coordinate vector, I write it down as A and B. Okay, this is going to be, suppose this is coordinate vector of U1 prime respect to the B. And at the same time, this is going to be U2 prime. U2 prime, I find these respect to the B, then they give me a vector. Okay, it's a two-dimensional, so I write it down as a C and D. Okay, now you give me a vector in general and you want to expand it here. So suppose V is going to be linear combination as V prime and V2. Okay, so basically this means, let me just expand this one first. Therefore, what does it mean? You see, this means this means U1 prime is a linear combination of A and the B. See, so this is what you have. This means U1 prime. U1 prime is a scalar multiplication is going to be A U1 plus B U2. Okay, U1 prime is a linear combination of U1 and U2, and these are the coefficients. And it's going to be the same for the U2. U2 prime is going to be, again, a linear combination of a vector in B, and these are going to be a scalar multiplication, a scalar's coefficient, if you like. It's going to be CU1 plus DU2. Okay, so this is it. So we pick the basic vectors in the new basis. We write it down, okay, we find the coordinate with respect to the B. So each one of them is going to be a linear combination of these two vectors. And this is going to be linear combination of these two vectors. Their coefficients, remember, their coefficients are going to be coordinate vectors. Now, but we would like to work on the V here. Okay, so again, we continue. And we continue, say, oh, note that if v is going to be any vector in the subspace, okay, in the v, and then what you do is, then you can write it down as a linear combination of these two. And note that if v is going to be the case, and okay, it's going to be a vector in v, then if you like, and let, if you like, and let we find the coordinate vector of the v respect to the b prime. Okay, what is this one? It's going to be something like, you know, a number k1 and k2. So this means, what does it mean? This means that v is a linear combination of the vectors to the b given. It's going to be k1 u1 prime, okay, k2 u2 prime. You see, that was the purpose. The purpose that we would like to find the coordinate vector of the v respect to the b prime. Okay, so we just write it as a linear combination. We want to know what's going to be this k1 and the k2. That's the action that we are going to be interested in. Okay, now bring the u1 and the u2 from here. So is going to be equal to, I want to find the k1 and the k2, the formula for it. So it's going to be k1, substitute, is going to be au1 plus bu2. Okay, plus k2 times substitute. So that give you cu1 plus du2. Okay, multiply it, simplify it, you know, put these u1, u2 together. Mathematically, this is going to be the result. Remember, we want to change this one from the b prime to the b, related to the old one, if you like. So if you multiply these, okay, you can factor out the u1. So you arrive at k1, k1a plus k2c times u1. And this is going to be plus, factor out it's going to be k1b, k1p plus k2t times u2. You see what we did? We just write the v is a linear combination of u1 and u2. When it's a linear combination, these scalar coefficients are going to be coordinate vectors. Okay, so this means, this quickly means the coordinate vector of the v respect to the b is going to be equal to what? These are a scalar, k1a plus k2c. This is the first component. The second component is going to be k1b plus k2d. Okay, as a vector, you can break it. You can break it nicely into this format. If you multiply these vectors together, a, c, b, d, okay, it's going to be times k1, k2. If you multiply them together, that gives you that result. But what is this one? Look at this one. You see this k1 and k2 is what? k1, k2 is going to be just the coordinate vector of the v respect to the b prime. So that give you a, c, b, d, okay, bd times what? Times the coordinate vector of the v respect to the b prime. You see, this is a relationship that, you know, we find out. If you bring it up, so this is what you did. If you want to find the coordinate vector respect to the old basis, this is going to be equal to, okay, a, b, c, d times it by what? Times it by v b prime. So that gives a relationship between the old one and the new one. So what is this? A, B, C. Look at this one. You see that's going to be A, B, and the C, D. So A, B, and the C, D are what? They are just coordinate vector of a new basis. Okay, the coordinate vector of the basic vector in the B prime respect to the old one. You see, so this means if you just find these two at the beginning, you can put it over here and get the result right away. But as you can see, this is just for 2 by 2, and you're not done. If you want to do it by 3 by 3, it's going to be quite a lot. But give us an idea how we can put them together. So what we do is this matrix, we give it a name. We call it P, and we call it transition vectors, if you like. Okay, let me write it down. I'm going to put it into a theorem in a minute, but it's not bad just to think about it a little bit, and you can study your book too to get this idea that we have. So what we do is we suppose that P is going to be A, B, C, D. Okay, this is going to be the one. And then, as you can see, then the columns. Okay, as you can see, the columns of P. The columns of P are just what are the coordinate vectors. Okay, the coordinates of the new basis vectors, new basis vectors relative to the old one, relative to the old matrix, to the old basis. Okay, P is going to be called, P is called transition matrix. Okay, P is called the transition matrix. The transition matrix from the new one, from B prime, okay, to B. Therefore, this is the way we write it down. We write, you see the coordinate respect to the old one, if you like, is going to be equal to the P times the coordinate respect to the new one. See, that's going to be a relationship between these two together. I'm going to write it down as a theorem. So basically, this is going to be like a function. They are all functions. They are all functions, but this is not a multiplication. This is a kind of composition of two functions. So this is a composition of two functions that give you this function right away. If you want to think about it, okay, the combination that you see you have somewhere this is going to be your vector space, if you like. This is the given vector space, and you pick one vector here. Okay, so what you do is you are going to take this one. Okay, you take this one and you're just using the coordinate vectors, let's say coordinate of the B respect to the B prime. Okay, that take you to what? That take you to the Rn. Because the coordinate vector is just what? Is the vectors of the scalars. So this is the vector space that's going to be a copy of the Rn. So in this case, you use another, you see, you use two bases. So this is going to be the second one. So the second one is the one that we call it V. Okay, the vector V and the coordinate with respect to the B. But again, that will take you to what? That will take you to the Rn. Okay, that's going to be to the Rn. So these, both of them are going to be a function that take you to this, okay? But you did it separately. If you want to connect them together, you have to pick a function. Okay, these are going to be the case that we're going to have. So this is going to be the Rn, and this is going to be the Rn, okay? So in order to be able to do it, so you need a function in between, if you like. So the function that you are going to be interested in is just that transition one that we talk about it. You see that transition one is, the transition one in between is going to be that P. Okay, that's going to be P. The P would take you, okay? The P would do this connection, if you like. Okay, so this P is going to be a function, for example, it's going to be from B prime to the B, if you like. So you have a kind of a triangle, we call it a diagram, when we're dealing with this composition of functions. So this diagram is going to be in this format. The format is going to be, if you want to start with one of them, you see, if you would like to take this one. So if you would like to take this function, okay, this is going to be the one. You have to go around to take back to this, just like a composition of two functions. So you want to go from this side. So what you can do is, you can go from this one first, okay? So you have this one first. So this is going to be first, okay? And followed by this action. Followed by this action is going to be this one over here. These are all composition of two functions, okay? The composition of two functions, this is going to be the inside function, this is going to be the inside function, and this is going to be the outside function to take you back to the original one. But the direction must be consistent, you see. You want to find this one, okay, going from V to the, and this is it, your vector space to the Rn by the basis B. So start from here and you end up here. But for example, if you want to do, if you would like to get this vector, okay, so you are here. Okay, so you are here. So you have to take the direction to take you back. If you want to take it back, you have to take the V of, you see, you have to take this function first, this action first. That's going to be your inside function. Then you have to come here. If you come here, your direction is different. You see the direction is different. This P is from B prime. Okay, it's going to be from B prime to the B. You want it the other way around, so you have to go the other side. When you go the other side, you have to consider the inverse of this function. So that gives you P inverse. You see, very nice interpretation of this idea that we put them together. Okay, so what we are going to do is we are going to write them generally, and then we are going to give a shortcut to find the P, because it's not an easy operation to do. Okay, even for two-dimensional, you see, you have to find all these coefficients that I talk about it to get these numbers. So what I did all together, I just nicely give you a geometrical interpretation of this famous theorem. We write it as a theorem. That's a change of base theorem. Okay, this is it. Change of base. The basis, there you are. Now officially we give you everything you need. There you are. We start with two bases. You see, if B is going to be equal to U1, U2, up to the UN. Okay, is an old basis, given one. An old basis. We just give them old and new just to understand. and B prime, a new one, U1 prime, U2 prime, up to the UN prime. This is going to be a new one, is a new basis. Is going to be a new basis for what? For a vector space, for a vector space V. Okay, old and the new one. Now then, if this is going to be the case, there is a P. It's unique. Then the conclusion. Then there is a unique one and only one. A unique n by n matrix, n by n matrix called P, such that, okay, such that this vector coordinate respect to the old one is equal to the P times, okay, coordinate vectors respect to what? Respect to the new one. Now, how are we going to find the V? Where, as we did it, where the columns, okay, the columns of P are going to be, as I did it, are the coordinate, okay, the coordinates, the coordinate vectors of new basis vectors respect to the old one. Vectors relative to the old basis. I'm going to write it down so that you know it. You see the new, these are going to be the new basis vectors. What you're going to do is you are going to take each one of these out as a vector. You write it as a linear combination of these B's. When you write it as a linear combinations, those coefficient scalar, okay, those scalars numbers that you're going to find would form a vector that would form the first column of the P. You get this second one. You find a linear combination of U2 prime respect to these vectors. That give you a scalars. Those scalars would form a vector. You put it at the second column of the P and you continue. You get n by n. You see, this is the way you're going to form the P. So basically, this is going to be the result. See? So the column, it's a little bit involved, but it's, if you understand it, it's a nice one. Okay, it takes times, but we are going to make it short. So the column again. So the columns, vectors of P are, you see, as I talk about it, this is U1 prime. You find the linear combination of U1 prime respect to the B. That give you scalars, C1, C2 to the Cn. You make it the first column of the P. Then you pick the second vector, U2 prime. You write it down as a linear combination of the members in B. There are going to be scalars. You're going to pick those scalars out. That give you the second column of the P, and you continue. So you continue to get all of them. Okay, these are going to be the column of the, if you put them together, if you like, these are going to be, okay, that give you the matrix P, Okay, as we talk about it, P is going to be called transition matrix. P is called, okay, P is called the transition matrix from B prime. Okay, from B prime to B. B prime to B. Okay, so this is the way we write it down. We write P sub B prime to B. This is the way we write it down. B prime to B, to understand that this is it. That's prime. You see, U1 prime B, the first column. U2 prime B into B, into B. And you can, you can switch it if you like. But this is going to be the case, okay? So similarly, you can switch it if you like. Okay, similarly, you can switch it as I talk about it to get the other way around. Okay, so you have to make sure you understand this notation is the P plus B prime to the B. Okay, exactly the way I put it over here. Okay, those graph B prime plus B and those gain. Okay, I just write it down again here. You see, this is going to be your V that take you to the VP prime. This is one of them. Okay, and then you come from here, you go to the B, but the P is going to be in between. You see, the P is going to be, so this is going to be your P from B prime to B, exactly P prime to B, and that is going to be the case that we talk about it. So the coordinate vector with respect to the new one is going to be in this, okay, in this format. So that's the one we call it change of base. So in order to find it, you need to find the P. Okay, if you find the P, that the transition vector, and because one of these would be given to you, then you've been asked to find the other one. Now, how are we going to find the P? I just give you a shortcut, because this type of operation, if you want to do it yourself, it would be quite a lot to be able to find it. Okay, so this is your job. We give a couple of problems and you're going to use this method. Computing the P. Okay, that's it. P, it doesn't matter from B prime to B or B to B. Okay, these are going to be the same thing. So suppose you want to compute, P from, it doesn't matter, okay, B prime to B, for example. This is how we're going to do it. Okay, so B and the B prime would be given to you. Okay, so that's going to be the one. So what you are going to do, you are going to form a step one. Okay, step one, you are going to form, you see this is B prime to B. You switch it, you form this matrix, form and the matrix. Okay, switch this. It's B prime to B, you switch it into the B, then the B prime. You see, that's the way we do it. Then what you're going to do is, you are going to do the row echelon form. Okay, you are going to do the row echelon form, and you try to replace, to reduce this B into the identity matrix. Okay, so that's going to be the one. Number two. Number two, reduce the matrix. Reduce the matrix. Okay, in part one, two, a reduced row echelon form. Okay, row echelon form. Okay, you know that it's going to be reduce row echelon form. Okay, when you do it, so what we're going to do is part three. The resultant matrix would be the resulting matrix will be if this format, you see, this is it. This part's going to be I. Whatever you got over there is what you are looking for. This is going to be P. Okay, but it's going to be P plus from B prime to B. And that's it. Okay, so what you're going to do, this is going to be the one. You are going to take it out, extract, if you like, extract the matrix, the one that you have P from B prime to B, from the right side, from the right side, and then you're done. Okay, so it's make it easy to find. But in general, if you want to do those actual job, it's difficult. So your assignments are going to be these B and the B prime would be given. Then they ask you to find these okay, transition matrix. Okay, and then the actual problem that you want to work with the coordinate base. Okay, let's get the example to see how we're going to do it. So that makes easy really to be able to do it. So let's have, so I just repeat it again. You just make sure that what you want, this two is important. They give you this one, which direction are going to go from B to B prime or B prime to B. In this case, I want to write from B prime to B. Switch it, B prime, whatever it is, switch. B prime, form the matrix, row echelon form. Try to change this one to the identity. So whatever you got for the second part is going to be just a matrix B, that's it. And if you want to go, then you go back and do those coordinates. So let's get one practice first, okay? So this is it. Example. Let's go to the other side and get some examples for you, okay? And this is it. And that's all you're going to do. Example, we give you two bases. So suppose you have the B is equal to, okay, this is it. B is equal to these matrix. Okay, for the, I just want to give you one example that, yes, you see B is equal to the U1, U2, and the B prime is equal to the U1 prime, U2 prime. Okay, where these are going to be our bases, bases in R2, where this is it. U1 is equal to the -9, 1, a vector. U2 is equal to the -5, -1. U1 prime is equal to 1 and -4. Okay, -4. And the U2 prime is 3 and -5. 3 and -5. Okay, 3 and -5. So what do you want? This is it. They ask you to find. Okay, find the first part. They ask you to find the transition matrix. Okay, the transition matrix. Transition matrix P from B prime to B. That's the first one. And the second one, and they ask the transition matrix. Okay, the transition matrix. Transition matrix P from B to B prime. Okay, this is what we are interested in. If you want to go with the original method, it takes quite a while to do it. Okay, but we are going to use that method, the shortcut that we talk about it. Okay, so this is it. Let's try the first one, solution. We want to find the transition matrix from B prime to B. Okay, switch it. Okay, so this is the question. So step one, you're going to switch into the, okay, B prime B, you form the B prime. Okay, B prime, and bring those matrices to put them together. You see for the B, we have the U1 and the U2. You see they are going to be the column matrix. Okay, so this is going to be the B and the B prime. Okay, so you put them at the column matrix to go on. Okay, so for the first one, the first column is going to be negative column matrix, not the row matrix. Most of the people, they miss it on the test. So it's going to be -9, the column 1. And then we get the U2 is going to be -5, -1. Okay, this is the way you write it down. And the second part for the B prime, column vectors again. Okay, the column one that give you 1, -4. Okay, and the column that give you 3, -5. Okay, make sure you put them in the column format. Okay, so it's going to be B. So it's going to be U1, U2 as we write it down, okay, as a column vectors. Now what we're going to do, we are going to work on the first part to change this one into the identity. Okay, different way to do it. So what I do is I switch these two, so I put the one on the top. Okay, so I'm going to replace it first to get these two together. So I replace the R1 and the R2. So I'm going to have, and this is it, I put the 1, -1, and this is going to be a -4 and -5. So down here, I'm going to have a -9, -5, 1, and 3. That is going to be the first step. Okay, now nicely, I got the 1 on the top. So I take care of this one. Okay, which is easy. So it's going to be R3. I change it to the R3 plus 9R1. So the top, I'm going to have a 1, -1, -4, -5. 9R1, make it to the 0. Okay, that gives you -14. I have a -14 over here. Okay, and this would be -36, make it to the -35. Okay, and this is going to be -45, make it to the -42. -42. Okay, I continue. This is it. I know that I have to change this one. Okay, we can write this one or not. So that's it. So what I need to do is I need to change this one into the 0. Okay, this one into the 0. So I have to, this is going to be the, okay, this is going to be the case. Okay, so what we are going to do is to make it into the zero, we have to subtract it. It's going to be R1. So this is going to be the R1. And we change the R1 into the what? Into the R1 plus 14 times R2 to make it into, okay, into the zero. Okay, it's going to be plus or minus 1 over 14 R2. Okay, we have to change this one to the positive one so that we'll be able to simplify it. Okay, so we have no other choice. So we continue. So we continue. What we're going to get now is going to be 1. Okay, this is negative 1 over 14, going to be positive 1, and negative 1 would be 0. Okay, but this is a little bit tricky. You got to be careful. So it's going to be negative 4. I write it down there, I simplify it. So if you multiply that, give you 14 over 35. Okay, 14 over 35. And over here, this is going to be a negative 5. And this is going to be a positive. Okay, a positive what? A positive 42 over 14. Okay, so that's going to be nice in a minute. So this is going to be a 0. We get the negative 14, negative 35, and the negative 42. Okay, these are going to be the 1. So a little bit simplify it and then nicely put them together. Okay, it's going to be simplified by 7, that give you 2. So by 7, that give you 5. Okay, and it's going to be negative 20, and that give you, okay, 18, simplify it. So that give you, I'm sorry, by, yes, by 5, that give you, by 7, that give 2, that give you 5. Okay, so this is going to be the, the leftover. So I have the, I just want to double check my numbers. So what I did is, I made a mistake here, I'm sorry, because it's the other way around. Okay, 1 over 40, 35 over, sorry, because this must be 35. So it's a 35 on the top and the 14 on the bottom, sorry, because the numbers must be nice. Okay, now this is it. So the bottom one would be 2, the top one would be 7, 2, negative 8. So I write it down here. So this is going to be the leftover. I have the 1 and the 0, 1 and the 0. So I simplified negative 8 and 7 okay. So that gave me 1, 1/2. Okay, so I have 1, 0, negative 8. And now it's by this 5, 5 times 7 would be 35. You can check it yourself. Negative 8 and the 5 would be 3. So it's a negative 3/2. Okay, and you simplify here, that give you 1, that give you 3. So that give you nicely a negative 2. Okay, negative 2. Then I have a 0 here. Okay, 0, negative, okay. So that is it. I got the 0, negative 14. Okay, my negative 14, negative 35, negative 42. We are almost there. Okay, we are almost there. We just divide this one by a negative 14, and then we'll be able to find the, okay, to find the result. So what I did, I just double check again. So I get the zeros here. Okay, so I have to divide this one by positive 14 to get the identity. Okay, so it's going to be R2, and this is going to be Okay, it's going to be negative 1 over 14 R2. Okay, so if you do it, eventually this is going to be 1 is 0, negative 3 half, negative 2, and it's going to be 0, 1. Okay, 0, 1. If you divide this one and simplify it by 7, that gives it a 5 half, and this is going to be simply 3. You see, eventually I got it. So what I have, this is identity. Okay, this is going to be a P. So I have the matrix P equal to negative 3 half, negative 2, and the 5 half, and 3. See, this is going to be transitional. It's going to be most of the time an easy one, but it's not difficult. I just wanted to see that you got to be patient and eventually to get these numbers done. Okay, you can switch it and do the other part, or they are going to be inverse of each other, or you can find the inverse. Okay, whichever you like. Okay, so similarly, so remember this is what this is going to be from B prime to B. This is going to be from B prime to B. If you want to find the other way around, you can find the inverse of this matrix, or you can go back and do the operations again. So I'll just write it down for you and just give it a final answer. Okay, so not difficult. Make sure 2 places that you miss on the test. You have to switch. First, more important one, they are column vectors. You see 9, 1, negative 9, 1, you have to put it as a column vectors. If you write them as a row vector, you are out. Okay, they are column vectors. So you have 2 choices. You can go ahead and form it as a beginning, or just find the inverse function. Okay, so what I would like to do is you can just make sure to get you want to find the that's B prime to B. That was part 1. The part 2, you see the part 2. The part 2, I asked for they asked for the matrix from okay, that's it. So they ask what is going to be the projection from B to B prime. Okay, you are going to switch it first. Okay, you switch first. So you form a B prime B. Okay, you form a B prime B, and the B prime is given to you. Okay, the B prime as the column vector is going 1, negative 4, 1, negative 4, and we get the 3 and negative 5. And then it carried by the B, which is going to be a negative 9, negative 9, 1, and you have a negative 5 and the okay, and the negative 1. Again, it can be done, quickly to change it. Okay, you already got the 1 here, so simply you just multiply the, okay, you get the R1 plus, you see this is going to be R2 into the R2 plus 4R1, and you get these columns quickly. So the first one is going to be 1, 3, negative 9, and the negative 5. And the second one, this would be 0. Okay, 12, that give you, okay, that give you 7. Okay, that give you 7, that give you 35, and negative 35, and that give you negative 20, 21. Okay, for R1. That is, okay, that is going to be the case, because this is going to be negative, okay. So that give you 1, 1, 3, 1, 3, 0, 7. Then we have a negative 9, negative 5, negative 35, and because this is, just double check this. So I have the R2 for R1, and that is 12. make it, yes, that's going to be the numbers. Okay, then just a couple of more. You have to change this one into the one, so you can divide. So the R2 into the 1/7 of R2. Okay, and then you continue. It's going to be 1, 3, -9, and -5, and then it's going to be 0, 1. If divided by 7, that gives a -5, and that would be a -3. Okay, so that's going to be the 1. And quickly you can change this one into the 0 by, this is R1, it's going to be R1 minus 3 R2. Okay, so you get the 0 quickly. So that gives you 1, 0. Okay, 1, 0. This is going to be 15, make it into the 6. Okay, into the 6. And this is going to be 9, make this one into 4. Okay, and this is going to be 0, 1, -5, -3. Okay, so quickly you get the result that you are interested in. So this is going to be identity. Okay, this is going to be the identity and the P. So the matrix P is going to be 6 and -5, 4 and -3. This is the inverse of the other one. Okay, so this is the P from B to B prime, which is going to be 6, 4, -5 and -3. And if you consider the P inverse, okay, that give you the same thing. You can double check it and get the result that this is going to be true. Okay, so this is your main job, to find this transitional one. But what is the actual problem? Okay, that we are going to do it. Okay, so to give you one actual example to finish it. As you can see, it's not bad and not difficult. It takes times. It's 2 by 2. You know, sometimes we check the 3 by 3, and then we'll be fine. We'll be able to do it. Okay, so I'll give you an example. This is a typical example. So suppose B is equal to the 1, 2, 1, 2, 3, and -1, and we have B prime. B prime is equal to the 3, 1 and the 5, 2. Okay, these are going to be all they are bases. Okay, are bases in R2 or of R2. Now, what do you want? You see, this is what we want. If the coordinate of the V respect to the B is equal to the 2, 1, we want to find, find the coordinate of the V respect to the B prime. This is it. This is the problem that would be given to you. Okay, so write the formula that you need, and then you go and find it. This is the way you write it down, depends which one is missing. So the solution is going to be, you see, you want to find the new one. So this is going to be the P times the old one. But remember where this P is from B to B prime. B to B prime. Okay, just don't miss it. Write the one that you need, okay, first. Write the one you need first, going to be P, that's a transition that we're going to have, the transition of the B into the B prime. You have to find this matrix, okay? So so you have to find the transition matrix from B to B prime. And remember that's missing, so what you're going to do is, you're going to switch it first. This is B to B prime. You switch into the B prime and the B. Make sure that you switch it. Now bring your matrices. Okay, this is it, B prime. Remember, column matrix. 3, 1, 5, 2. That is the B prime. Then you go with the B column matrix. 1, 2, 3, negative 1. Okay, that's your main job. To find this, you have to switch it. Okay, you better switch these two. So change the R1 into the R2. Okay, if you change it, that gives us 1, 2, 2, negative 1. And this is going to be 3, 5, 1, 3. Okay, so this is going to be the case. So you have to change this one into the 0. So R2 into R2 minus 3R1. And to make this one into the 0, so that give you 1, 2, 2, negative 1. So that make it to the 0. 3R1 is going to be negative 6. It's going to be negative 1, negative 5, and the 6. Okay, this is it. You need a 1 here, so you can multiply by 1 to get the 1 here, and then take care of that 0 on the top. Okay, so this is the R2 into the negative R2, and continue. Okay, need this one to be positive 1, that would be 0. So we can do both of them at the same time. Okay, so this is going to be R1 minus so I just do it in 2 parts, and that give it the result right away. Okay, so this is going to be the conclusion. If you multiply the second one by a negative sign, that gives 1, 2, 2, negative 1, and this is going to be 0, 1. Okay, that's going to be 0, 1, 5, and negative 6. This is it. Okay, so what else? We have to change this one into the 0. So it's going to be R1 is going to be R1 minus 2R2. And quickly give us what we are interested in. Okay, so that gives us 1, 0. 1, 0, negative 8, 11. And this is going to be 0, 1, 0, 1, 5, and negative 6. Okay, that's it. So this is identity, and this must be the matrix P. Okay, so the matrix P is going to be negative 8, 11, 5, and negative 6. Okay, that's going to be the P. Remember, you are looking for the coordinate matrix of the B respect to the B prime. We talk about is going to be P, the coordinate of the V respect to the B. So this is it. It's a negative 8, 11, 5, and negative 6. You multiply by the given one. The given one was 2, 1. And if you simplify it, negative 16 and the 11. Okay, that gives us a negative 5. And the second one is a 10 and the negative 6, that gives us a 4. So the coordinate matrix with respect to the B prime is going to be equal to the negative 5 and 4. And you're done. And this is how we take care of these type of problems. And we give a couple of more in the, when we go to the practice one. Okay, so also you can read your book, but basically what we need is this type of last argument. Really, there are only one case that we are going to use it in future. This is going to be good for if you want to do something, in mostly in geometry or respect to this type of ideas. You change the base several times, to get to the to make things easier, if you like. This is the idea of the change of basis, but we are not going to use it quite a lot in this course. Okay, so that's a 4.4.6. I'll post a practice test for you, okay, tomorrow, and then we start preparing you for the for that test. Test going to be on Monday as usual. We start with the 6 on Zoom, 6 to 9, and as usual give you 11 questions. Okay, so you study your quiz and the practice test. I didn't give you your points for the quiz. I do that one too, and there is not going to be any assignment, and then I'll give you another recording, to talk about it. So have a good one. Take care, and just watch this video as soon as possible. Bye bye.